Doesn't matter. So, hello everyone. We are Jolocom, so my name is Eugenio, and this is Natasha, and we work together on self-sovereign identity here in Berlin. And we want to quickly look at the state of basically self-sovereign identity today. So the title of the presentation of the workshop was, what will self-sovereign identity look like? And the answer to that question is we don't certainly know yet. So there are a lot of unknowns, ways of doing things, possibility, but we can look at what it looks like today, what some of the trends and standards are, and in general, sort of where is the field moving. And we want to do a little workshop, so I think the best way to kind of explain all of this is to actually go through the process of creating an identity, adding some information about yourself, perhaps using that information, authenticating against some service, receiving some information from that service for you, and then perhaps later using it somewhere else. And we'll be doing that in two ways. So we'll be doing it using the wallet application. So then Natasha will be actually doing this. I think there's a little echo. So we'll be doing it using the wallet application. So the wallet application is available on the Android store. We have an iOS build as well, but we haven't published it yet, so that takes a little bit longer. But it's if you just search for the Jolocom smart wallet, you should be able to find it. And then the second thing, so in parallel, we'll be also looking at how you can actually get through this process using a library, so the Jolocom library, and just kind of like highlight this in the beginning. So absolutely everything is fully open source, and everything is based on open standards, which is very exciting to me personally. So I think then we can probably start. So you can probably start on the wallet side. So in case anyone wants to follow along on the wallet side, feel free to go to the Android store and look for the Jolocom smart wallet, or just search for Jolocom and you can follow. If anyone wants to follow along on the library side, there's a little repository I've set up. You can clone it, and it should make your life a little bit easier. And if anyone just wants to kick back and listen, then that's perfectly fine too. And as we do things, I hope to be able to go in sort of like some of the data structures and as much as detail as necessary to actually explain what's going on here. So.
All right, so, well, I'm a little bit ahead of you because I have already downloaded the app and created an identity. So if you just go to the Play Store and download it and just follow the instructions. This is basically the screen that would pop up after you run through the registration process. And what we see here is my identity wallet, which is completely empty right now, right? And what we're gonna do together is I'm gonna add some information to my app, and we're gonna use this information in some interactions that we're gonna show you. So let's just add the name here. Oop. So I'm gonna add it, and I'm gonna add an email. All right. So basically, this is how it looks then, and
yep. Yeah, we're going to actually look at what does this actually mean. So first of all, what is creating an identity? Are you registering? Where are you registering? How are you registering? So basically, we use the DID-DDoS specification for modeling identities. So for every user, we basically generate a decentralized identifier, which might look something like this, for instance. So firstly, each user has an identifier which can be used to dereference their identity. So in this particular case, we have the identifier of this particular user is a very long string. It's not very rememberable or human-friendly, but because of the way that it is created, it is very likely to be unique and won't repeat across various identities in a decentralized manner. So the way that we actually create this identifier, when the user creates an identity on the wallet side, they'll first have to collect a certain amount of entropy that we can then use to derive keys, so to basically derive a key pair. And in our case, the identifier, the DID, is just the hash of the public key, so there are numerous ways you can do this. It doesn't have to depend on the public key per se, but this is the way that we can do this. And once you have a DID for a certain identity, for a user, then you need to also specify a DID document, so you need to define the thing that you will get once you resolve the DID. So if I have someone's DID, I can, for example, fetch this DID document, and this has some information, for example, about the public keys. associated with that identity and perhaps what keys are used for authentication and different types of authentication. And then it also has a proof of integrity in form of a signature. So the interesting thing here is that we can see that the DID starts with DID YOLO in this case. And by that prefix, you basically can find out what resolution mechanism you have to use to actually get this document. So if you encounter one of these in the wild, you might know by this that this is a Jolocom DID. The way that we anchor them, so this document we store on IPFS, and then there's a mapping in an Ethereum smart contract from the DID to the IPFS hash. And that mapping can be updated by the owner of the identity. And the interesting thing about this is that, of course, this is very similar to a DID from another identity system, from another identity provider. So because this is standardized and because the resolution mechanism is quite straightforward, for us, for instance, it doesn't really make much of a difference if we're interacting with a Jolocom identity or if we're interacting with an identity from another identity provider. If we want to validate the signature, we resolve the DID, we get the DID document, we find the public key, and we validate the signature. There are universal resolvers already available. You can just throw a DID at it, and it will try to resolve it. So it supports a large amount of schemes, such as, for instance, sovereign, UPort, like a variety of mechanisms to actually resolve them all without having to have all individual libraries installed locally and try against all of them, because that can be cumbersome. So from the Jolocom side, so from the library side, actually creating an identity is quite straightforward. So I'll quickly go through this. So I've abstracted some of the uglier stuff away, but generally speaking, what we have here is so what the create identity method actually abstracts away is we have to pass entropy, 32 bytes of entropy, and then the create method basically creates an identity, so derives the keys for you, derives an identity key, derives an Ethereum key. So we are currently anchoring the identities on the Ringkabit testnet. So in order to actually have a transaction to add the identity into the registry contract, of course, you would need to have a certain amount of gas. Ideally, we want to use signed executable messages here or meta transactions. That would make life a lot easier. At the moment, we generate two keys, an identity key, an Ethereum key, and we pre-fill the Ethereum key with 0.1 Ringkabit Ether. So that happens implicitly behind the scenes from one of our faucets. But in the very close future, I think most of this will be changed to meta transactions, so then we don't have to bother with that. Also behind the scenes, the DID document is created, stored on IPFS, the mapping in the smart contract is set, and basically the identity is ready to use, really. So is there anyone following along with this? Because then I might have to, we might have two people, okay. So then I might have to explain the structure here a little bit. So we have a data file there, so I'll quickly open it.
Sorry, can you increase the font size a little bit?
Yep, 1 second. Good. So I've created this file here to store some of the information while we go along with the library so that you don't have to copy-paste things manually. So at the moment, we don't have entropy, we don't have a private identity key. We will be authenticating against a demo service which supports the ID authentication, so those endpoints are already there for a later use. So the first thing you want to do is take out your secure hardware module, so whatever you have, you need 32 bytes of entropy. For now, so on the smart wallet side, of course, that's managed by collecting entropy, setting a CSRNG module, and then generating. On this side, we can choose whatever we want to generate some entropy. I'll go. So one simple way to do this is to just type 64 hex characters, but one also easy way to do this is to just use node. Yep, zooming in. So we can just require the crypto package, and then I'll just do crypto dot random bytes, and we'll get 32 random bytes, and that's a buffer, so to string, and then hex. So this should give us a not very secure 32 bytes of entropy. So do not use this in production. This is just for a demo case, but I can copy this thing now and actually put it back into the data file, and this will be used in the first step. Do not copy the entropy. Don't copy it. So if I can move on, then I'll just paste the entropy here like this, and this will be imported in the relevant file. So now I can go for and I can just start the registration process. So this will take 40 seconds, give or take. We have 2 Ethereum transactions on Rinkeby, so those can take anywhere between, I don't know, up to 15 seconds longer. And then we post some data on IPFS, so we store some data on IPFS, and that is normally quite fast. And once this is done, then we should get back the identity key and our DID. And the identity key, the private key, of course, you wouldn't store it like this, so you'd have either a vault, or you'd encrypt it, or you do something along those lines. But at the moment, we just create it like this, and that is our DID there, and that is our private key. So if I would take this DID, for example, I could also use the Jolocom library, for example, to resolve this. So I could say something like registry.resolve, and then I would pass in the DID. But rather the DID. And if I were to do this, then I get basically the DID document back with the private keys, the public keys that I can then use to validate signatures later. But if you got this far, so that means that your identity has been created and anchored on Ethereum, and now we can try to use this identity for some maybe nifty things. So the first thing we need to do is to grab the private key and email it to us now, and put it into the data file here. So now we can. So now it can be used in a later stage. So if we look at the second part, so this is actually the interesting part. So far we've created an identity, and that is the step that you haven't seen on the smart wallet. So that happened behind the scenes. If somebody is following along on the smart wallet side, you perhaps saw the loading screen and all of that and got to the home screen. Now we can actually look at something that we observed Natasha do. So this is basically adding information about you. So Natasha said that her name is Natasha, or her phone number is, or her email address is something, for example. So how is this information modeled? How is this information stored? So this is modeled as a W3C verifiable credential. It's a signed JSON-LD document, or linked data document, basically. I can show you an example of one really quickly. So this, for instance, would be a signed credential, and the signed credential basically has an issuer, and the issuer can also be a DID. So in our case, the issuer will normally be a DID, and then it has a claim. So the claim basically has whatever the claim is, and then the ID of the subject. So this is equivalent to saying that this entity says this about this identity, and then there's a signature, and the signature was created by one of the keys belonging to that identity, perhaps. And this is so this is not a self-signed credential in this case, of course. So the one entity states something about another entity, and this is cryptographically signed. So normally the receiver would have this, so the subject would have this, and then they can present it. If they want to enter a bar and they say, are you over 21, you don't have to show your ID card, you can just do this, for instance. Given that they trust the issuer, then all shall be fine. And the good thing here is, again, these guys don't have to be on the same network. So the issuer and the receiver don't have to be on the same, don't have both to be, for instance, Jolocom identities. Or because this is to a certain extent standardized, we can expect that if we fetch this, we get a DID document that we can make sense of. And if we were to fetch this, for instance, we would also get a DID document. Perhaps not in this particular case, but normally yes, but perhaps in this case too. So you get like a DID document, and you can proceed just as normal. So you are not really locked into any particular identity system, and you can take your data, go somewhere else, and you should be totally fine. And if you now look at the second snippet we have here, so this is a fairly simple one. So we can see here in the beginning we say register. So basically the Jolocom registry is a resolver. So this knows how to resolve identities that were stored, let's say, on IPFS in the sort of Jolocom way, so to say, how to store, how to update them, and so on and so forth. So normally every project will have their own registry or resolver, as you might hear it being called as well. And in this case, we authenticate. And authenticate is perhaps not the best word. What we do actually, we pass the private key. Behind the scenes, from that private key, we can derive a public key, we can derive the DID, go on the ledger, check if the DID is registered, is there a DID document, fetch it locally and populate. So this kind of gives you an identity wallet of sorts. So this populates, and then now you can start acting on behalf of that identity. You don't really have to do this. You can create statements manually and sign them with the according private key. This just makes life easier a little bit later, like further down the line. And here we are creating two credentials, actually. So we are creating two verifiable credentials. The first one is a mobile phone number claim. So this is a fairly simple one. It basically just says that the telephone would be this. Now, it's important to notice that there's no subject here. So we are not actually, who is this going to? So in this particular case, this will be a self-signed or a self-issued credential. So this will be, I say that my phone number is this and it's signed by me. And it's the same in this case. If we want to add an extra subject, it's just a matter of doing this quickly. Or, for instance, and so on and so forth. And then this could be received by so this can be transferred to the receiver in some way, and then they could present it later to authenticate maybe against something or to prove something in some way. So if I were to actually run this, I think it's going to be a little bit crowded, but we can see that we basically console log both credentials. So this is perhaps the more...
No, wait.
This is perhaps so this is not pure JSON, so this is still like an instance of a class, but generally speaking, we see the relevant parts. We have the type of the credential, we have the issuer, we have the subject. So in this particular case, we should observe that the issuer and the service of the subject are the same person, and then the creator of the signature is also the same DID, actually. So this is in that sense a self-signed credential. And on the wallet side, basically when you add information about yourself, you're just generating self-signed credentials, storing them in the local database encrypted. They never leave your device in any way, shape, or form unless you actually use them to authenticate against the service. And I think this is basically what we will look at now. So we have a little demo website you've deployed. 1 second. There we go. And you can, of course, log in with LinkedIn. Or Facebook. You'll have to tolerate my jokes, I'm sorry. But once you log in with Jolocom, you basically get a QR code. And this is a very usual suspect when you talk about self-sovereign identity and wallets and the such. QR codes always pop up. So Natasha will scan this in a second. Just try to fit both the phone and the... Yeah, there we go. Wait. Yeah, so she will scan this in a second. And once she scans it, she will be prompted to provide some information to the service. And then she will be able to continue. So if you do this.
Okay.
So the service requires a name. We only have one name available locally currently, so this is the one that Natasha created herself. It's self-signed. And she can provide the credential to the service. And once she does that, if the demo gods are with us, we should basically see something like this. So what happened? How? So we basically use the ID authentication. So the primitives are there. So we have identifiers, we have public keys associated with the identifiers. We have a way to arrive from a public key to an identifier to more public keys, discover some more information. So some form of like challenge response mechanism or something along those lines where you send a challenge string and then the counterparty signs it, sends it back, something along those lines. For instance, is conceivable, so something like that could work. So what we use currently is DID authentication. If you just give me 1 second, I'll have it in the resources. There we go. So this is a document for the rebooting the web of trust. It's a combined effort, so we have people from, so Mark Sabadello, so we have people from like Sovereign, the NoobTech, us, Uport. So it's just kind of like looking at the ways of doing the ID authentication currently, what's out there in the field and what and how does it work. And there are some small snippets here, so some examples of various things which are encoded in the JSON Web Tokens. So 1 second. So this would be, for instance, the Jolocom. What we call this is the credential request, basically, but what's encoded in the QR code is service saying, this is who I am, here's a challenge string, this is what I need from you, and it's cryptographically signed. We include some constraints here, so the idea behind this was perhaps to make it easier to model things on the client side. So like the service could say that not only I want an email from you, but perhaps I want an email where the issuer and the subject are not the same person. Or where the issuer is this person, because I only trust this person, or the issuer has to be in an ACL file of sorts, for instance. There's maybe a more concise way to do this, but currently this is the way that we approach this. So there's another snippet here, so there's other projects as well, and you can see that the general idea is very similar. You basically provide a callback URL where should the user send the data, and then you try to define what kind of data do you actually want from them. So there are efforts to standardize this, because it doesn't make sense really, but if you think about it, it encodes the same data, looks the same QR code, why wouldn't it work across two wallets, right? Just because we have a comma somewhere and someone else doesn't. So there are efforts to standardize this, to actually have a common flow. If they have login with your DID, doesn't matter what wallet you use, maybe you wrote one yourself, you should be able to just log in and use the service. So that would be the authentication phase. And now we can see sort of like we are welcomed here, so we ask a little question. The answer will be persisted, so if you don't feel comfortable with that, don't fill it in. Your DID is not, so although it's sort of like a ephemeral DID, we still don't persist it, but feel free to answer. So I'll say here, of course. Well, but when we do this, we get another QR code, actually. So welcome to the world of self-sovereign identities, JSON web tokens and QR codes, basically, at the moment. But once you scan this, actually, on the wallet side, so this is the service giving you a verifiable credential. So you will receive a verifiable credential from, actually, the Jolocom demo SSO service. So it has an identity as an issuer. It will issue a little sort of like token which says thank you for participating, that you can actually have in your wallet, and maybe later you will be able to use. Let's say at one of our workshops, perhaps we'll have a way to redeem that for something interesting. So if we just follow along with that.
All right.
So once that is scanned, we should see a little sort of outline here. So we have the issuer. So at the moment, we render the DID itself. So there's no mappings to, say, like a human readable, human-friendly name. And that's not because having this type of mapping is very difficult. It's because there's a million ways to have this type of mappings. From a registry contract, something a lot cleverer. And we don't really want to end up with a million of like heterogeneous implementations. So hopefully something a little better crystallized, but there's ways of associating sort of like human readable names with identities. We have an expiry date. We have it's a proof of tinkerer credential, a little note from us. So if you were to accept this, this will be persisted on your side. So now you can present it to someone at some point and say that I was at this workshop, and your friends will think you're cool. So I'll look at doing the same thing with the library, because if you don't have an Android device, or you might still want to get that. So if we look at the library, there's the third snippet we can run. 1 second. Just don't mind this. It's fine. Okay, there we go. And this one's maybe a little bit more convoluted, but again, we have the first step where we basically instantiate an identity wallet. We put in our private key. The private key is sent to the Jolocom server. So the private key is converted to a DID DDO, and then we fetch the DID document, we populate an instance of a class, and now you can use this to create certain things. So the first thing we do here is we actually fetch this credential offer from the service. So in that QR code that Natasha scanned just a second ago, what we actually had was a credential offer. If I could, damn it. I have it on Slack. No one look. No one. Damn it. But yeah, I'll pull that up in a second, actually. But the general idea what we have there is, again, a JSON web token. We have the issuer, so the service, and a few sort of extra things. So the first thing, it'll tell you if it's an instant receival or not. So in this particular case, we just scan something and we receive data, right? And we have a verifiable credential, and that's that. So it's non-interactive in that sense. The user doesn't have to input anything. The user doesn't have to do much. The only thing that the user has to do is scan the QR code. Independent of who the user is, they will receive the same credential. Now, it's totally conceivable, let's say if you would like to verify your email address or your home address, or really any kind of attribute, you might want to provide some input first to the service. So let's say if I'm doing this with Airbnb, I would provide my email, they go through an internal verification process, and then once they mark me as verified, they could perhaps also issue me a signed credential that they have verified my email, and this will be valid for X, Y, Z amount of time. And then at a later point in time, when I go to another service, I can just present this. And given that they trust Airbnb, and given that there's a good mechanism for figuring out who's liable and how they get punished, I mean, this could save money, both the service, and could save some time the user. So in that case, in the case where the user has to introduce some information, of course, we can't have it that snap. You can't just scan a QR code and get a verifiable credential right away. So in that case, you might have to provide some information, and then the transaction is not instant. So then you as a user would have to either query the endpoint, which is a simpler solution, but the best solution to do this, of course, would be through push notifications or message relays of sorts. So like if the service could, for example, issue a push notification to you through a infrastructure, like through a deployed service, for example, that your phone could check against, and it's like your credential is ready, and now you can come and fetch it. So if I were to do the same thing on this side, so basically what we do here is we get the credential offer, and I can actually console log it here, so that's going to be all right. So I should be able to run this now. So firstly, we can look at this is what the credential offer actually is. So this is after it's been extracted out of the JSON Web Token. So this is all of the signature stuff has been taken care of when we decode. So we know that the signature on this is valid. We have a challenge string for the user to sign. We have the requested input. So if this is empty, that means that we don't want anything from the user. We could have some extra information here. There's perhaps like, so we're currently looking at ways to both advertise what information we desire and also advertise perhaps what format it should be, as in, or perhaps even offer ways for the users to reuse information that is currently part of a verifiable credential and import this into this, so to make your life in general easier and enable for better reuse of data instead of having to type the same thing all over the place. And then there's a callback URL, which is where do you go to actually get your credential. And then this is what we basically get back. So of course, if we were to stringify this, we would see it in much greater detail, but we have a signed credential, a verifiable credential, which basically contains the proof of integrity, the ID of the credential, and then the issuer. So this would be the Jolocom, for example, identity, or the identity that is registered with the demo SSO service. The proof, this would be in my particular case, my DID that I created just now. In your case, this would be, of course, something else. There's a little note, and there's issued and expires. And that would actually be that. So this is what you get now. You could reuse this against another service, for example, at a later point in time. So I think this about wraps up actually the run through both the library flow and the Jolocom wallet. So I think now, since we have some time left, it would be great to just answer questions and go into details about whatever you feel like, asking questions and going into details about. So any questions? Any? Yep. So what you would need for so the minimal thing you would need to have let's say a locally accessible mapping maybe between DIDs and DDO documents that you could trust. So the way we do now, the way that we do things now, of course, is we go through, let's say, IPFS Ethereum. So in this case, in order to be able to verify something, you have to be connected to the internet if you're using a gateway, or you have to be running a node. If you're not connecting to the, so of course you also have like local, let's say, identity setup. So not all identities need to be resolvable everywhere in the world, right? So if you have, let's say, an organization and you say that these identities are allowed to open these doors and those are allowed to open those doors, and you have a good revocation mechanism for all of those things, those DIDs, they don't matter outside of that organization, perhaps. So the bare minimum for that identity to be valid within that particular deployment or on those premises is it needs to be resolvable in those premises. Now, the resolution mechanism here, the resolution mechanism between you getting a DID and you getting the DID document associated with the DID doesn't have to go over the internet. So you're free to decide however you want to do this and whatever protocols you would like to choose for that. It could be call Eugenio and ask him. Of course, that's not a good protocol, but it could be pretty much whatever suits your use cases best. But unfortunately, so to say, so for the best way to validate a signature issued by the DIDs to actually be able to resolve the DID document. So you have to have a way to do that in one way or another. Another way to do this, which perhaps be a little bit hackier. So if you look, so in our case, the DID is derived from the public key. So if you have the public key, you can find out the DID unless the private key, so the public key, the controlling the DID was swapped or like changed or rotated. But if you have a system where the DID is derived from the public key through means of hashing, for example, and you don't have, let's say, a way to rotate keys or keys don't rotate often, then you could be perhaps bold, somehow like try to derive the DID from the public key, see if things match up. But it would probably require a certain amount of modifications because also here, for example, if you have a JSON-LD document that is signed, the public key actually doesn't figure here. So you don't have the public key neither in hex form nor in whatever other form. So what you have is you have the creator, which is a relative point in the creator's DID document. So you still have to, so you could of course have the key in here, for instance, or do something along those lines. But like an idiomatic, nice way of doing this, I would still reason you perhaps have to be able to resolve them.
Where are you storing all the credentials?
You mean these credentials?
Yes, this file, the credential file. Where are you storing it?
So at the moment, everything is basically stored on the device. Yes, we have a database locally, stuff's encrypted, so it leaves your device only in whenever you exchange data with the service, with this fire and forget way. This is only a starting point, of course, because there's very little data availability here, right? Like if somebody wants data from me, you can do some push notification stuff really, but it's not so easy to do that. So I think we're looking here more at the infrastructure that can augment this. So things like identity hubs or perhaps servers that can run and run data, like provide that at high availability, provide perhaps some form of like authentication, access control based on DID DDoS, for example, that could be deployed on the network. So you could store your data in a way that you could potentially, like you could hopefully trust. So we initially started actually looking at and working with personal servers, solid servers, linked data servers, and trying to kind of do that type of like self-sovereign identity where you spin up your own server and this is who you are. And it's good, I like it, but people don't really run servers, unfortunately, and people don't really monitor for security updates and restart and do stuff. It's really cumbersome. But we do hope that servers will find a good way, we will find a good way to really augment this infrastructure using, let's say, message relays for push notifications, perhaps meta transactions or like fueling contracts, and then also services, for example, for making data available highly. So that would be that. Does that answer the question? Cool. Any other questions? Yep.
From an implementation perspective, you need the issuers or someone who's going to validate the credentials to kind of come into the system, right? How do you see that process playing out?
So there are different ways of approaching this, actually. So there are different ways of modeling this system. So some people really try to, like, in some cases you would see, for example, like they really try to mimic existing organizational structures, existing sort of things. Onto the chain, I have a clear mapping between this and that. You're only allowed to join the chain if you're a company and if you've signed this agreement with this person and you did this. We believe in the web of trust type of thing. At least we're excited about it. I think it's really cool. But essentially, like for a verifier to join this network, the friction is not very high, but sort of the interesting thing about this is that there's actually no surefire way to say whether the identity you're interacting with is, let's say, the German government or not. Like fully, you'd have to rely on some form of registry, on some form of statement made by someone, like a TCR or something along those lines. So you could have something as simple as, let's say, the organization advertising that this is their DID or that this is their public key outside of the chain, so like in an area that they actually control. And there are some efforts on this already. So I think I think Kai from our team actually has been actively involved in a project that is looking at how can we actually model these relationships between organizations and kind of move them on chain where you have one that is trusted. It can perhaps increase the trust of another one by sort of like similar to a certificate authority kind of thing, if you were to look at that. So I'm sure he could give you a lot of answers in terms of that, but like from the technical point of view, somehow they would need to prove in a place that they control, and we know that they control it, and this is where we go to find them that they also have an identity here. Perhaps there's probably more sophisticated ways to do this, but that's what I have off the top of my head. I think you had another question, or?
Probably you get almost the same question. What about GDPR? And
So,
GDPR thinks that just a public key, even a public key or a hash, it's private information you cannot share.
yeah, so at the moment, like, we do, so the things that are stored on chain are basically public keys and DID documents. We don't store any like PII, but we apparently, like, so we don't store any like PII on chain, but then keys and hashes can be considered PII. So the interesting paradox of this type of self-sovereign identity systems is that you want to make DIDs, deeds and keys, fungible. You want to just chew through them. You want a different DID with every interaction, with every service. This is what's really being pushed for. So somehow you don't want to have a persistent identifier that can be used by various services to figure out if you interacted with them. Because let's say you authenticate against some service and they can collude with another service first, which is bad, but they could also just post this DID, that's his name and his address, and good luck. Of course, it's the same as in real life, but so generally speaking, the direction there is to use discardable, pairwise pseudonyms or like DIDs that you just create purely for this interaction. That has some complications on the credential side though, because the credentials are issued to one particular identity. So reusing DIDs across personas is not the easiest task in the world per se, because if this is issued to you, if I come and say I'd like to authenticate and here's my permission, they say, well, this is not to you. So I can somehow prove that I have control over the other key, but by doing that, I effectively say that I'm this person. So like I destroy the whole reason for creating an alternative identity if as soon as I create this, I associate it with an existing identity. So there are efforts on this as well to somehow decouple the receiver from the DID, so perhaps do something like aggregated signatures or something along those lines, but as of now, we are still very actively trying to figure out actually what is the best, what is the right way to approach this, because like what I like to think is that like I'm really thankful for like blockchains because they actually really make me question what I want, because I want immutability, and immutability is great until it isn't. And then I don't want immutability, but then I want immutability again. And the question, how do we actually, is the same with proxy contracts and other things. You know, like we want immutability only when it makes sense, but defining what this actually means is kind of the trickier questions. But GDPR is a beast, so we'll try to somehow like figure out how do we actually best approach this. I mean, it is what it is. So we have. Yeah, so there are also efforts in the Bundesverband, for example. There's also the blockchain Bundesverband, like just positioning papers in general. Sorry if I butchered the word. Don't really speak German that well, but positioning papers that try to reason about an architecture that would make sense. So there are there are efforts on sort of like trying to somehow reason with this on a legal side, particularly here in Berlin and in Germany. But we see how it unfolds. This is why I say we're not exactly sure how these systems will look like in the future, but we know what they'll look like now. I've also seen that some, for example, some self-sovereign identity systems will, so the users don't actually have DIDs. So the DIDs are only issued to companies or services or verifiers, because if you think about it, I mean, when is a DID necessary? Well, a DID is necessary firstly, of course, when someone wants to verify something that you've said. So they need to be able to find your identity, resolve it, find a public key, and ensure that it's correct. Perhaps when you find yourself in need of a revocation list, that's when you might want to have that. DIDs also have a mechanism for you to advertise further service endpoints. So I could say, if you'd like to message me, this is my message relay. If you'd like to do this, go there. If you'd like to do this, go there. So in that sense, it might make sense to have a DID again. But in some cases, it might not make sense to anchor a new DID on chain. Sometimes a new key might suffice, but the limitations are then there. So like it's a lot of ifs and maybes and unknowns, but we see how it goes. Okay, well then, if that's that, I guess, if no one minds, we can finish 10, 15 minutes early and enjoy the break? Or, yeah, well, wonderful. Thank you for the attention.